All right, guys, so we talked about how we can solve a system by graphing. So we're graphing two lines, looking for where they cross to figure out what x equals and what y equals. But sometimes that's not the best way. Like we saw in one of our many graphing examples, that if they don't cross at a super nice point, so again, like I was doing this one here, where these two lines just didn't cross each other at a nice point. So I kind of had to guess what my answer is. And we don't want to guess. We want to know exactly what it equals. So we have to come up with some other ways to solve a system, solve for x and y algebraically. So the first way that we're going to do that is by using substitution. So on pages 71 and 72 in our notebook here, we're going to be talking about substitution. If we turn and look at that page right now, 71 doesn't have anything on it. We're going to do I'll probably do a separate video where I do a couple more examples. But we're going to start on 72 right here because really one of three things can happen. If I have one equation that is set equal to a variable, so what that looks like is this one equation already says y equals. If that happens, that is the best case scenario because I kind of know what y is. So in the second equation, wherever I see that y, I'm going to swap those things out. Because if I'm equal, then I can interchange them. Like we're the same. I always kind of think of it as like playing basketball or playing soccer. Now, when I played soccer, I was a defensive wing. But if I get injured or if I needed to come out for a rest, another defensive wing would come in for me because we are equal. Now, obviously, I was the better player, but just kidding. So because this equals y, I can put it in place of y in the other equation. So I write out this equation again, but in place of y, I put 2x plus 1, and then I finish the equation. And then we're not in such a bad spot anymore because I don't have two different letters anymore. I only have x. So to think about solving now, I would distribute, and we would have x plus 6x plus 3 equals negative 12. And then if we bring it up here, I can combine like terms because these x's are like terms. So I have 1 here, 6 there for 7x plus 3 equals negative 12. And then I would work on getting x all by itself. So I'd subtract that 3, both sides. And I'd have 7x equals negative 15. And then to get x all alone, I would divide both sides by 7. And it ain't going to be pretty, but we get negative 15 over 7. Now, that's only what x is. I also want to know what y is. So if I go back to the start here, now that I know x, I can replace it with negative 15 over 7 and just simplify. So 2 times that will be negative 30 over 7 plus 1, although I'm going to want to make that 7 over 7 so that I can add these fractions with the same denominator. And I get negative 23 over 7. Why did we do this one first? It sucks. Let's go inside and try some more like that. So these two are like that because at the top I have x equals. So this right here can come in for x in the other equation. So when I rewrite this out, we'll have 5. And then in place of x, we want to put the whole equation, 3y minus 9 minus 2y equals 7. And then I'll distribute because now I'll be able to solve. There's only one letter to solve for. So we'll have 15y minus 45 minus 2y equals 7. Then I can combine like terms because the y's are the same, and we have 15y minus 2y for 13y. Then to get y all by itself, I would add 45 on both sides. And so we'll have 13y equals 52. Divide both sides by 13. And hopefully 13 goes into that evenly. I think maybe 4 times. Yeah, 4 times. So that worked out nicely. Now that I know y, I can take it and plug it in to this original equation so that I can figure out how much x is. So in place of y, we'll put 4. And then we're just going to simplify, like 3 times 4 is 12. Minus 9 is 3. And that's what x was. So finally, because this first one was such a mess, I can write my answer as an ordered pair, because really these are 2 lines that are crossing somewhere, and they are crossing at 3, 4, because x, y. So to try another one, this top equation is not a letter equals stuff. However, the bottom one is, it says y equals this. So in the top equation, I can replace y with that because they're equal. So I'm going to take this top equation, rewrite it, but in place of y, I'm going to put that 2x minus 4. And then I can start solving because I have all x's here. So first I got to distribute. So negative 6x plus 6x minus 12 equals negative 12. Uh-oh. I'm going to have to combine like terms. And negative 6 and positive 6 is 0. So my x is gone. And what I have left is negative 12 equals negative 12. And there's no x for me to solve for anymore. So if there's no x for me to solve for, that kind of makes me feel like maybe we don't have a solution. Like if you remember, there were 3 things that could happen. One solution, and that last one had one solution, 3, 4. No solutions, or infinitely many solutions. So if we actually take a look, this is in y equals mx plus b. If I take that top equation and rewrite it in y equals mx plus b, so like add the 6x, and then divide the 3, I end up with y equals 2x plus 4. Did I miss something here? Oh no. Oh, look at those. Those lines are parallel. I think I goofed up somewhere. Oh, this is a negative 12. That's why. I was like, I know what's supposed to happen and it's not happening. And it's negative 4. Those are the exact same line. I was like, I knew I missed something. So since they're the exact same line, they are on top of each other, which means that this has infinite solutions. And guys, I knew that that was going to happen because when I was solving algebraically, the x's all disappeared, and this is a true statement. Negative 12 does equal negative 12. So I do have an answer. I just have infinite answers. Okay, sorry that was a little weird. Let's try another. Now, another type of substitution type problem is maybe when no equation is set equal to a variable. So like this doesn't say y equals or x equals anywhere. So if that happens, what I need to do is get a letter alone first. So the way to tell which letter will be easiest to get by itself is to look at all the letters, and if there is no number on it, that's the one you're going to want to get by itself. So get a letter alone first. Look for a letter without a number. So if I look through all of these, this one here does not have a number on it. So I would get y all by itself by subtracting the 2x. And that would be the easiest one to get alone. Now you can really get any of them alone that you want. It doesn't matter. But in all these other cases with the numbers in front, you're going to have to divide eventually. So it'll take more steps. So if we take a look in here, looking at this first one, the easiest letter to get alone will be this y right here, because I just have to add the 3x away. And so then this new equation will be y equals positive 3x, because I added it, minus 13. And then we're in the situation we were talking about before, where I can take this and put it in for y, because that's what y equals. So I take my top equation, the 4x plus 5y, but in place of y, I'm going to put 3x minus 13 now equals 11. Then I can solve for x because there's only one letter to solve for, but I got to distribute. So I'll have 4x plus 15x minus, 5 times 13, 65. We'll find out in a minute. Then I can combine like terms because these x's are like terms. So 4x and 15x is 19x. Minus 65 equals 11. Then if I want to solve for x, I'm going to get it alone by adding that 65 away. So we'll have 19x equals 76. Divide both sides by 19. Man, I hope 19 goes into that evenly. Otherwise, I feel like I goofed up on something. But maybe not. I mean, I don't have to get a nice, easy answer. It could be that you just have a fraction and it's no fun. I say that and I love fractions, but oh, that does go evenly. That's just 4. So x is 4. But I also need to solve for y. However, in this first equation, I rewrote it so that y was by itself. So I'm just going to plug in x now as 4. And then 12 minus 13 is negative 1. So y is negative 1. So my final answer is one solution at 4, negative 1. That's where these two lines are going to cross, at one spot, 4, negative 1. Okay. So if we take a look over here, the easiest ones to get alone are really x or y. It kind of doesn't matter. So I'm just going to subtract y, and we'll have x equals negative 5 minus y, just to be weird. And then I'm going to take this and put it into my other equation in place of x, because that's what it's equal to. So when I rewrite this bottom equation now, we'll have 4. And then in place of x, I'm going to put this negative 5 minus y. Minus 5y equals negative 20. And then I can solve because I only have one letter. But first, I got to distribute. So I'll have negative 20 minus 4y minus 5y equals negative 20. Okay, I can combine like terms. Negative 4 and negative 5 is negative 9. Sorry about my I just think ahead and then I'm like, So now to get y all by itself, I want to add the 20 on both sides. And this is why I said, because I'm going to have negative 9y left, but negative 20, positive 20, that's 0. But I still have a letter left to solve for, so I'm going to write down 0. And then to get y all by itself, I need to divide the negative 9. And that's okay to do because 0 divided by anything is just 0. Like 0 on top is okay. So y will just be 0. Then I want to go solve for x. So if I go back to that equation I got alone, I can put in place of y 0. And like negative 5 minus 0 is just negative 5. So these two lines are crossing at negative 5, comma 0. So they have one solution right at that spot. Okay, so these two situations at the top here are basically the same, you guys. You want one letter alone so that you can substitute it inside. So this is like an inside substitution. You just might have to get a letter alone first if you don't already have one. This last one is a little different. So with this one, if both equations are set equal to each other, then I just put one equal to the other. So since this one is equal to y and this one is equal to y, they are equal to each other. So it's like x plus 5 equals negative x plus 3. Because I'm kind of just putting this one in for that one. I think that makes sense. So then I can solve here, but my x's are on opposite sides, so I'll add this x over since it's smaller to get them together. So 2x plus 5 equals 3. Then I would subtract the 5 to get x alone. So 2x equals negative 2. And then divide the 2. So x equals negative 1. Then I can pick either equation because they're both pretty easy. I'm going to go with the top one because there's not a negative. And I'll plug in negative 1 for x. And then add 5. So 4. So these do cross and they have one solution at negative 1, comma 4. Cute. Oh my God, let's try 2 more. Okay, so these two equations are both equal to x. So since they're both equal to x, they're equal to each other. So I can just rewrite this as 3y minus 6 equals y plus 2. Now, it wouldn't be wrong to say y plus 2 equals, like if these were just swapped sides, that's fine too. Now, if I want to solve for y, I need to get them on the same side. So I'm going to subtract this y over because it's smaller. And we'll have 2y minus 6 equals 2. Then to work on getting y alone, I'll add the 6 away. So 2y equals 8. And then divide by 2. So y is 4. Then I got to figure out what x is. And I can pick either one of these because they're both equal to x. And that bottom one just looks a little easier. So in place of y, I'll put 4 plus 2. Means that x is 6. Sorry, that was a weird x. And so these two lines also cross one time at 6, comma 4. Last but not least for this video. These two equations here are both set equal to y. So I can set them equal to each other. And so I'll have 2x plus 5 equals 2x minus 5. Then I want to get my x's together on the same side. So I'll subtract the 2x. Oh. That's 0. And I'm left with 5. And then over here, that's 0. And I'm left with negative 5. Ugh. I don't have an x anymore. So this one is actually kind of like this one from before where I didn't have any letters left to solve for. And actually, if we take a look back at these two lines have the same slope, but different y-intercepts. And if I have the same slope, I'm parallel. And if I have different y-intercepts, I'm definitely parallel. Like that's this situation right here. not two lines on top of each other, because two lines on top of each other would be exactly the same, like 2x minus 4 and 2x minus 4. These lines are parallel, which means no solution. They do not cross each other. And I can also tell because like 5 does not equal -5. So this is a false statement. So no solution. So guys, I'm going to post another video as well where I'm going to do some more examples on 71. But if you're feeling okay about it and you don't need it, then don't watch it.